In this video, we're going to cover Chapter 10, where the topic is aversive control and specifically avoidance and punishment procedures. Now, up to this point in this course, we've talked mostly about reinforcement. We've alluded to the existence of punishment, and we've talked about how it might apply in some situations, but we left the bulk of that discussion for a future chapter. And surprise, this is our future chapter. This is where we're actually going to start talking about things like punishment. And before that, we're going to talk also about avoidance. This behavior, then that bad thing won't happen. So this sounds very similar to negative reinforcement, where doing the behavior removes something bad. Just in this case, when we're specifically talking about avoidance, it's not identical to negative reinforcement because avoidance is actually preventing that aversive stimulus from occurring. If we were specifically stopping an already occurring aversive stimulus, we would call it an escape behavior. An escape behavior would be negative reinforcement, where doing a behavior allows you to escape from an already occurring aversive stimulus. But avoidance helps you prevent an aversive stimulus from happening in the future. Okay, so that's avoidance and a little bit on escape behavior as well. But what about punishment? So for punishment, we're saying that our target response, our behavior, is going to produce the aversive outcome. Punishment is more of a positive contingency, where if I do this behavior, then a bad thing is going to happen. And this sort of vague bad thing could be the delivery of an aversive stimulus if we're looking at positive punishment, or it might be the removal of a good stimulus if we were looking at negative punishment. But in both cases, with punishment, doing a behavior is going to lead to some kind of bad outcome. And we're going to come back to punishment. The second half of this chapter deals with punishment, but we're going to start by talking about avoidance behavior. Now, some of the earliest studies of avoidance behavior were conducted by Vladimir Betrev. I'm so bad at pronouncing names, but this name might sound familiar because he worked in Pavlov's lab. So he worked with Pavlov on our Pavlovian conditioning or classical conditioning, but he was specifically interested in studying associative learning in humans. Now, for his setup, it wasn't a true classical conditioning setup. What he had participants do was place their finger on a metal plate. And so that metal plate could then be electrified. And so he had it set up so that there would be a conditioned stimulus, a light that would warn of an upcoming unconditioned stimulus, a shock. And the idea was that when people were shocked, they would lift their finger. So you usually withdraw from a painful stimulus. So early on, what we would have observed would be something like the escape trials shown here. So our conditioned stimulus is the presence of a light. And so they would turn on the light, and towards the end of that light being on, the unconditioned stimulus, the shock, would go off. And the response, whenever the plate was electrified and the shock was delivered, would be to remove your finger from that plate. So it's an escape trial because, yes, the conditioned stimulus is present, the unconditioned stimulus happens, and the response is given in response to our unconditioned stimulus. So people would lift their finger because it was actively being shocked. So they were escaping from that aversive stimulus by moving their finger away. Over time, what they found is that people started to display avoidance, where if the conditioned stimulus was on, they would lift their finger, even without the shock being present. So there's no unconditioned stimulus here, there's no shock present. So whenever that light would turn on, they would learn that it was letting them know that a shock was coming, and they would lift their finger so that they wouldn't be in contact with that plate if a shock was then going to be delivered. So they could avoid being shocked altogether by learning that this conditioned stimulus was basically warning them of an upcoming aversive stimulus. So the light warned of the upcoming shock, so they could do a behavior to avoid receiving that shock. Now, this ability to lift your finger means that the participants were actually controlling whether or not they received that unconditioned stimulus. So that aspect of control was a pretty significant deviation from Pavlov's methods. So this doesn't fall under the category of classical or Pavlovian conditioning. Because if we look at true classical conditioning, making a conditioned response doesn't cancel or change the delivery of our unconditioned stimulus. So this is a lot closer to our instrumental conditioning that we're going to talk about for most of the rest of this chapter. To illustrate the difference between our standard classical conditioning and this new avoidance setup, we can look at an example from the textbook, looking at a very specific experiment where we have guinea pigs who were running in wheels. So they have a rotating wheel apparatus, kind of like a hamster and a running wheel. And in this setup, they had a tone served as the conditioned stimulus, and the conditioned stimulus would be presented before a shock. So the shock was our unconditioned stimulus. Our conditioned response would be to run. So in classical conditioning group, these open triangles, the tone would precede the shock, and the shock would occur no matter what. But the response to being shocked would also be to start running. So we see that we have a fair amount of running behavior, so a percentage of conditioned responses, basically how much running are they doing. So those in the classical conditioning group ran pretty much consistently. So there's some ups and downs, but overall a pretty flat amount of running. So the classical conditioning group would run when they heard the tone because the tone preceded the shock, and the conditioned response to something that's associated with being shocked is to run. It's not written here, but our unconditioned response would also be running. So we see pretty flat levels of running. They haven't really learned anything other than the tone precedes the shock, so they have the same response to the tone as they would the shock. Where it gets cool is in our avoidance group. And in this group, a new contingency was added where if the tone played and these guinea pigs rotated the wheel, then they wouldn't receive the shock. So if they did the conditioned response of running, they could avoid receiving that unconditioned stimulus of receiving a shock. And what we find here is that their rate of running skyrocketed. They very, very quickly learned that running allowed them to avoid that aversive stimulus, our unconditioned stimulus of a shock, and so they ran a lot whenever they heard the tone. So this is a much higher rate of running than what we saw for our classical conditioning group. And that's because the avoidance group could actually avoid that shock by running, whereas the classical conditioning group could not. All right, so let's go back and do some definitions. We've already kind of described the difference between escape and avoidance, but let's do it officially with words on the slides and all. So escape is usually the first part of that learning procedure. So if I scroll back here to when we first were introduced to this avoidance behavior, I mentioned that our escape trials would be what happened first. Before we understood that the conditioned stimulus warned of an upcoming unconditioned stimulus, we relied on the presence of this unconditioned stimulus to trigger that response. So escape, it happens when we terminate an aversive response or an aversive stimulus by performing some kind of response. So you can escape the occurrence of a shock by doing a particular behavior. And so you learn very quickly that if say something bad is happening in this room, well, maybe I go into the other room. Use the example of, say you're making breakfast and you burn your toast and you set off your fire alarm. Well, the fire alarm goes off and it's really loud and annoying in the kitchen, so you open up your window to let some of the smoke out so that the room will clear. But if you don't want to listen to that awful sound, you go and stand in another room where it's quiet. You are using an escape procedure where you are getting away from that aversive stimulus, that awful sound, by going somewhere else. So this is our first step that we learn. Our second step is avoidance. So this is when you can actually prevent that aversive stimulus from happening by performing a response in advance. So this is learned second, and that's because you have to learn the escape part of it first, and then you can learn that something is telling you of the upcoming delivery of something aversive so that you can do a behavior in advance to avoid it happening. So avoidance is a little bit more complicated and is therefore learned second. In our fire alarm example, maybe you're making toast and you notice that your toast is burning. And you know that you have a sensitive fire alarm, so you grab a towel. You stand underneath your fire alarm and you flap your towel to keep it from getting smoky and setting off the alarm. So you can avoid having to hear that sound by doing some behavior that avoids that aversive stimulus from happening in the first place. Another way you could do it that's more in line with what we're going to talk about for our standard escape and avoidance procedure would be you're making toast and you know that it's going to set off that alarm, so you grab your toast and run. You leave that room before the alarm can go off, so you don't have to hear it at all. But some kind of behavior that allows you to avoid an upcoming aversive stimulus because you've done some behavior that lets you avoid that situation. All right. So whenever we talk about escape and avoidance, we're typically going to be studying it in terms of a shuttle box. This is one of the most common ways to study escape and avoidance, especially in non-human animal literature. And I think we've talked about these before, but just in case, I'm going to go over it in just a little bit of detail so that we know what's going on. But for this setup, we have a box, and there are two sides to the box. On the bottom here, we have an electric grid on the floor, and this means that a shock could be delivered, and that shock can be delivered to only one side or only the other. We can control which part of this box receives that aversive stimulus. The doorway allows the animal to move freely from one side to the other, and we would have the presence of, say, a light or a speaker so that we could give off some kind of conditioned stimulus to warn of an upcoming delivery of an aversive stimulus. And this is called a shuttle box because the animal can move from one side to the other. They can shuttle from one side to the other. And this works for both escape and avoidance trials because of this setup. So we'll move our diagram up here so you can still see what I'm talking about. And we already have this escape trial and avoidance trial from earlier, but now we can think of it in terms of working in a shuttle box. So at the very beginning, we would likely see escape trials because you need a whole lot of extra learning to get an avoidance trial. So for the escape trials, we would have our conditioned stimulus turns on. This could be, like I said, a light or a tone, something that's giving advanced warning about an upcoming aversive stimulus or unconditioned stimulus. So here our light comes on and it's telling us that a shock will be delivered, the floor will become electrified. And usually the way that this works is the light turns on the side of the box that will become electrified. And because at the very beginning we don't know anything about this conditioned stimulus, the light doesn't mean anything to us. What happens is that unconditioned stimulus will be delivered, the floor will become electrified, and as a response, the animal will move to the other side of the apparatus. They will shuttle to the other side of our shuttle box where the floor isn't electrified. So by moving from somewhere where an aversive stimulus is present to somewhere where it's absent, they can escape from that aversive stimulus. Okay, that part makes sense. Next, over time, we learned that this conditioned stimulus serves as a warning. It is a precursor to an unconditioned stimulus. So it is warning us that an aversive stimulus will be delivered. So the animal can learn that when this light turns on, the floor is going to be electrified. So if they were spooked, they could then move to the other side of the cage before the floor is electrified so that they can avoid having to experience that shock from the floor because they've already gotten out of the way. So there's no need for the unconditioned stimulus to be delivered because they've done a behavior that avoids that occurrence. So they move to the other side of the cage and they don't experience an unconditioned stimulus. They don't experience that aversive stimulus because they've made a response that sort of prevents that from happening. Now, for these shuttle setups, we can have a two-way shuttle avoidance or a one-way shuttle avoidance. These are kind of a logical way of doing it. So in a two-way shuttle avoidance, then the animal moves in both directions on successive trials. Basically, they would have a light on either side, and if the light on the left turns on, they should move to the right, and if the light on the right turns on, they should move to the left. So we can have them shuttle back and forth, sort of learning that directionality. In a one-way shuttle avoidance, the animal would always be placed on the same side of the apparatus at the start of the trial. So they would always be placed on, say, the right-hand side, and the right-hand side's light would come on, and they should always run to the left. It's actually a lot easier for animals to learn a one-way avoidance because with this setup, they learn that one side is always safe. So if it's always you move from the right side where the shock is delivered and you go to the left side where it is safe, then the left side is always safe. So it's a lot easier to learn that right is bad and left is good than it is in a two-way avoidance setup where they switch between trials, where some trials right is good and sometimes left is good. So having that one-way directionality makes it a lot easier to learn this avoidance setup. Now, this whole escape and avoidance setup involves two separate mechanisms. So we're going to involve classical conditioning and instrumental conditioning as parts of this setup. So we can start with our classical conditioning component. And this is at the very beginning when our conditioned stimulus, that warning stimulus, whether it's a light or a tone that gives us a heads up, is paired with an unconditioned stimulus, a shock or other kind of aversive event. Now, if the organism has not learned to make an avoidance or escape response, this unconditioned or the CSUS pairing comes to elicit fear. When they see or hear that conditioned stimulus, they have a fear response because they have associated it with the delivery of that unconditioned stimulus. So step one is this classical conditioning of fear to our conditioned stimulus. And that fear response will serve to motivate the later parts of this behavior. Now, the second mechanism of our two-process theory is instrumental conditioning, or a component of instrumental conditioning. And in this theory, they specify that our instrumental conditioning is being driven by our conditioned stimulus. So we learn our avoidance response because making that response terminates the conditioned stimulus and therefore would reduce the conditioned fear, our conditioned response, to that conditioned stimulus. So actually, if we scroll back, we can look at this diagram here. So in our avoidance trials, when we make our response, it cuts short that conditioned stimulus. So if we have a tone that indicates that a shock is coming, as soon as we make that response, whether it's running to the other side of the cage or whatever, that ends the presentation of that conditioned stimulus. And if we have a fear response associated with that conditioned stimulus, then making our response will cut off that conditioned stimulus and lead to a reduction in the fear that we're feeling. Now, this is a slightly different take than what we talked through when we were just sort of describing what might be happening in terms of these avoidance and escape behaviors. Because now we're explaining this behavior in terms of escape from conditioned fear rather than escape from or preventing shock. So here we're being driven by that conditioned stimulus, that tone or the light that's warning us of an upcoming aversive stimulus, and the fear that we have come to feel whenever we see or hear that conditioned stimulus. So step one is all about establishing that fear to our conditioned stimulus. And step two is us learning that making a particular response gets rid of our conditioned stimulus and therefore alleviates the fear associated with that conditioned stimulus. So we have a reinforcement of this avoidance behavior through a reduction in fear. So by doing that behavior, we're reducing our fear levels, and by getting rid of that terrible feeling, we're ending up reinforcing that avoidance behavior. So a little bit of negative reinforcement going on here, because we're removing that fear in order to do that behavior, that avoidance behavior, more often. Okay, so the two-process theory sounds reasonable enough, but how would we actually go about verifying if that might be the case or not? Well, we can use what are called escape from fear experiments, or EFF experiments. Now, these experiments are set up in such a way that there's only going to be the option of escaping from fear. There is never going to be the option of escaping from shock. So what we're testing in this escape from fear experiment is whether the shock or escape from shock is what's driving our avoidance behavior, or if it's the escape from fear that's driving this behavior. Now, these experiments are set up to separate the two contributions of the two processes. So we're going to look at our classical conditioning component first, and then we'll look at the instrumental conditioning stand-in afterwards. So our first step looks the same as normal. So the first step is to train a CS-US pairing, associate a tone with a shock. But in this instance, there's no avoidance possible. So in this setup, the presentation of a tone is always followed by a shock, and there's no way to escape or avoid experiencing that shock. So you're just learning that there is an association, that there is a link between that tone and shock. So this is the same as before. Our classical conditioning component, our CS, is paired with our US, and we come to elicit a fear. We experience fear because of that pairing. So the conditioned stimulus elicits a fear response because of that pairing. So that part isn't really different except for the no escape, no avoidance part. Next, this is where it starts to change. Next, we would have the organism exposed to the conditioned stimulus, so just the tone, but now they have the option of turning off the unconditioned stimulus with an instrumental response. So if they're in a shuttle box, now they're allowed to, when they see that conditioned stimulus, they have the option to run to the other side of the box. So they could move from one side to the other in order to escape when that stimulus is present. But the interesting part here is that no shocks are ever given. So even if they don't display that avoidance behavior, even if they don't move to the other side of the box when the conditioned stimulus plays, they're not going to receive a shock. So in this case, the only thing that's driving this behavior is that fear that they developed from stage one. There are no shocks here to maintain this avoidance response. And so this second phase lets us see if reduction in fear alone is enough to drive our avoidance responses. And most of the literature shows that this is the case, giving us more support for our two-process theory of avoidance. So to summarize this two-process theory of avoidance, we can say that this theory explains avoidance behavior based on the organism escaping from fear rather than the avoidance behavior occurring to prevent shock. So it's more in line with them trying to not feel fear as opposed to trying to avoid getting a shock. So even though it looks on the surface like a true avoidance behavior, there is still some escape behavior going on because they are still feeling that feeling of fear, even if the shock is not delivered. So the prevention of shock in this setup is a byproduct of the avoidance behavior. So because they're trying to escape that fear, they're just happening to also avoid getting shocked. So the reduction of fear is reinforcing that avoidance behavior, and that seems to be what's driving that setup. Okay, now we are nowhere near as far into this chapter as I had wanted to be when I stopped for the day. However, this is my third attempt at recording this lecture. And I think I'm at my limit of trying to record this, so I believe I'm going to call it here. We're going to finish off the last couple of slides that I set aside for part 1, as well as the remaining 20 or so slides that I have intended for part 2. We'll do those all together in the next lecture, and I'll make sure that I keep that within a good length of time as well. But yeah, today's just going to be a little bit shorter because technical difficulties happen, and yeah, hopefully Thursday's class goes just a little bit better.